Hello everyone, I'm Eren Eser. For many years, hectic assembly work has been going on at NASA Goddard Space Flight Center for the construction of the James Webb Space Telescope. What is the James Webb Space Telescope? What will it do? The topic of this video is James Webb Space Telescope. Will it change the universe? If you want to support my channel, you can like the video and subscribe to my channel below. Don't forget to turn on notifications to be notified of upcoming videos. This telescope, which we can briefly call Webb, will be such a sensitive and advanced instrument that it will enable the formation of the first stars and galaxies of the universe and the direct observation of planets orbiting other stars. James Webb. First, a little history. Who is this James Webb? James Edwin Webb is the second administrator of NASA, who served from 1961 to 68. Webb, who carried out America's first manned spaceflights, Mercury and Gemini programs in his own time, also initiated the Apollo programs that enabled humanity to reach the moon. Not only concerned with manned missions, Webb also got NASA to start work on the Mariner and Pioneer robotic probes. With his great contributions, NASA has grown from a weakly connected community of research facilities to a well-coordinated organization. In short, his place and importance in NASA is quite large. Webb, who died in 1992 at the age of 85, was honored by giving his name to the project called Next Generation Space Telescope until 2002. Awesome observatories and the Next-Gen Space Telescope. The Hubble Space Telescope is one of our greatest Earth-orbiting instruments, but it's not the only orbiting telescope. Each of the 4 large telescopes launched into space under the title of Great Observatories, which dates back to 1946, has been prepared by considering certain spectra of the electromagnetic spectrum. Launched in 1990, Hubble observes in the visible light, near-ultraviolet and near-infrared spectra. Compton Observatory, which was in service between 1991 to 2000, was making gamma-rays observations. Its current successor is the Fermi Gamma Ray Telescope, launched in 2008. The Chandra Observatory, launched in 1999, focuses the X-ray spectrum. The Spitzer Telescope, launched in 2003, observes in the infrared spectrum. Although the media has focused on the Hubble telescope, the Compton, Chandra and Spitzer telescopes have revolutionized our knowledge of many astronomical objects and have enabled the discovery of thousands of new objects. Today, a new and highly advanced member is about to join this family of groundbreaking instruments in astronomy. The Next Generation Space Telescope, called the James Webb Telescope, will be placed in the stable Lagrange 2 region beyond the Moon, 1.5 million kilometers from Earth, and will make observations in the infrared spectrum to see beyond dust particles at cosmological distances. It will be able to observe all time periods of the universe with the devices and mirror diameter it will carry. Remember, the further we observe in space, the more we look into the past. James Webb Telescope. This international telescope, which we can call Webb for short, is being developed in partnership with NASA, ESA, and the Canadian Space Agency. When assembled, it will have a mass of 705 kilograms and a 6.5-meter diameter main mirror, with a light-gathering area 5 times larger than Hubble. The telescope will make its observations by focusing on the near and mid-infrared spectrum. There are 3 main reasons for this. First, the visible emissions of very distant celestial bodies with high redshifts are found in the infrared spectrum. Second, cold objects such as planets and debris disks around stars are best observed in the infrared spectrum. Finally, the infrared spectrum is difficult to observe from Earth. Existing telescopes such as Hubble and Spitzer are no longer sufficient for our purposes. The Kepler telescope, which allows the discovery of hundreds of exoplanets, can only observe a very small part of the galaxy due to the problems it has, and with the equipment it carries, not direct but only indirect observation of the outer planets is possible. The most expensive telescope ever. The Hubble Space Telescope, which has been in service for 25 years, will soon lose its place in the Guinness Book of Records with the Webb telescope with $2.1 billion. The value of many things cannot be measured with money, but with the money spent, it can be understood how much importance is given to a project. The estimated fee for R&D, assembly, launch in 2018, later postponed to 2020, then 2021, and 5 years of operation that followed is exactly $8.7 billion. Only $800 million of that money is for the first 5 years of operation. Of course, don't let this amazing figure fool you. Webb won't be the most expensive thing in orbit. The title belongs to the $150 billion International Space Station, which costs $2.9 billion annually. At this point, it is necessary to say the following to our readers who find space studies too expensive and who will say that the money spent on these studies should be used to eliminate poverty and help the hungry in Africa. In 2014, the world's only one-year military expenditure reached $1.7 trillion. In this terrible waste, America ranks first with $610 billion, China second with $216 billion, and Turkey 15th with $22.6 billion. Do not covet the money spent on science when we spend $1.7 trillion killing each other, and absolute peace could only make $1.7 trillion for all humanity in money. If you are committed to alleviating poverty and hunger, strive to resolve the energy resource supply/demand imbalance and find a way not to hate first your neighbors and then the rest of the. Now that we have given our social message, we can move a challenging project process. Webb was in danger for a long time with this need for funding, which was much higher than expected. The first next-generation telescope concept in the 1990s was projected to cost $500 million. With the replanning made in 2005, this amount increased to $3.5 billion for production and $1 billion for 10 years of operation. In 2007, 9 of the 10 technologies required for the project were sufficiently developed, and in 2008 the preliminary design phase of the project was successfully completed. Webb also passed the technical part of its mission-critical design review in 2010, with the Integrated Scientific Equipment Module also approved in 2009 and the Sun Shield parts in 2000. As you can see, the development and production process for such a detailed, sensitive scientific device that cannot be changed after launch has to be quite long and deep. For this reason, in the final design and production phase in 2011, the design, production and operational use of all parts were thoroughly re-examined. In 2014, the Scientific Equipment Module underwent a 4-month vacuum. While this whole process was in progress, even as the needed funding was secured and the telescope parts were completed, the project remained at the center of discussions with ever-increasing budget planning, which caused problems in many NASA projects, also felt its cold breath in the Webb telescope. So much so that in 2011, the Congress went so far as to completely cancel the American leg of the project, NASA, due to fee planning problems, in short, to finish the Webb telescope project. Fortunately, these budget problems were eventually over. Webb's launch now appears warm. The sun side of the shield will be plus 85 degrees Celsius, while the science equipment and mirrors are in this super cold environment. In other words, there will be a difference of 300 degrees between the two sides of the shield. Thus, it is better understood why the construction of the telescope was carried out with such precision and detail. This sunshield will be kept folded in its capsule at launch and, when unfolded, will cover an area of 12.2 by 18 meters. Optical. The 6.5-meter gold-plated beryllium mirror, a 25-square-foot collector area, is too large for current rockets. For this reason, the mirror consists of 18 hexagonal parts and will be folded inside the rocket. Sensitive detectors and micromotors will be used to place these 18 mirrors in the correct positions before the operation starts, and fine focus adjustments can be made with these detectors and motors according to the target determined during the observations. You read correctly, yes, we talked about gold plating, but this gold plating covering an area of 25 square meters is equivalent to 48.25 grams with a thinness of 0.00001 centimeters. So billions of dollars are not spent on gold. It will even be possible to analyze the atmospheres of exoplanets with the James Webb Telescope, which will be about 7 times more powerful than Hubble. Thus, it can be understood whether there is liquid water on their surface. A possible new planet, which has been the subject of discussion lately, will undoubtedly be best observed with James Webb. We are really curious to see what this telescope, which is perfectly suited to the 21st century, will show us.